So today we are going to start with a fantastic thing. We people have all heard about factorial. But as you have seen in the thumbnail, I have said that this lecture will be about hyperfactorial. Now, a long time back when I came across this word, hyperfactorial, I was little bit confused. What is it? We know factorial, but what is hyperfactorial? So when I go into it, I saw a whole lot of mathematics is involved in it. And as we all know that IIT-JEE people, they always test giving different things in every year. So this particular thing, hyperfactorial theory part, this can come any time in our examination. You will say, sir, many people don't know that. These people, what they will do, they will simply give you this whole thing in a paragraph. All the definition will be given, and now you have to work on that. So it is better to know the thing beforehand. And that's the reason why I thought that it is important to know what is hyperfactorial in beforehand. And that's the reason why I'm making this video. So let's start the class. What is hyperfactorial? Let us say, what is factorial n? We all know that factorial n is basically 1 into 2 into 3 into 4 till n times multiply. Now, hyperfactorial is basically denoted by hn. hn. What is that? Let us say, if I say, what is h of 4? What do you mean by that? It means that it is 1 to the power 1 into 2 square into 3 cube into 4 to the power 4. This is called hyperfactorial 4. If I say what is hyperfactorial of 5, you will say it is 1 to the power 1, 2 square, 3 cube, 4 to the power 4, 5 to the power 5, and so on. Is it clear? So what is hyperfactorial n? It is 1 to the power 1, 2 square, it will be 3 cube, 4 to the power 4, 5 to the power 5, and this thing goes on till n to the power n. This is what is called your hyperfactorial. Now, as I told you in the beginning of my class, that there is a whole lot of mathematics involved in it. Like one thing I'm sharing with you. We all know that factorial n can be written as 1 into 2 into 3 into 4 and so on till n. Now we have learned how to find, because you see, if you multiply those all terms in factorial n, you are going to get a natural number. Now if I ask you, what is the exponent of 5 in factorial n? You know the Legendre's formula. You know the Legendre's formula by virtue of which you can say what will be the power of or the exponent of 5 or any prime in factorial n. What is that formula? We all know that it can be written as n over 5 plus n over 5 square plus n over 5 cube, and this thing goes on. Okay, in factorial n. This is the way, by using Legendre's formula, we can find out the exponent of any prime in factorial n. Is it clear? This we all know. If you don't know, make a note of this. if I say factorial 100, and if I ask you what will be the exponent of 7 in factorial 100. So all it will do is it will simply do 100 over 7. This is the greatest integer function. This is the box function. Remember, these are all greatest integer function. So plus 100 over 7 square plus 100 over 7 cube. So no need to write anymore, because actually this series tends till infinity. So here we were going to have, if 100 is divided by 7, so we will have 14.28. So that will give us, the box function will give us 14 plus 100 when divided by 49, that is 7 square, it will be 2 point something. So box of that will give us 2. And from this onwards, we are going to have 0. Therefore, we are having 16 as our answer. Therefore, the exponent of 7 in factorial 100 is 16. This is what is called your Legendre's formula to find out the exponent of any prime in factorial n. This we all know. If you don't know, again I am mentioning, please do remember this formula to find out the exponent of any prime in factorial n. Now, my question is something else. My question is how to find out the exponent of any prime in hyperfactorial. Now, I am going to give you a formula. This is basically the extension formula for Legendre's. Whatever Legendre's formula we have, this is the extension part of that. I'm not going for its proof part. If you really want the proof, you please comment me in the comment box. Then I will make a separate video to prove this formula. But for a time being, as our JEE Advanced is nearby, we will remember this as a formula. What it states? It states that for any hyperfactorial n, which is actually this one from the definition, if I want to find out the exponent of any prime, let us say for an example, we want to find out the exponent of 7. 7 is the prime. So I want the exponent of 7 in this hyperfactorial. So how to get that? So Legendre's extension formula states that it will be the total, the exponent of 7 will be 7 into sigma t equals to 1 to box n by 7. This is t. Sigma t, where t starts from 1 till box n by 7. Next, 7 square. Sigma t is from 1 to box n by 7 square t. Then 7 cube box of, t starts from 1 to box of n by 7 cube t, and this thing goes on till infinity. Again, I'm telling you, if you are interested for this proof, please do comment me. I will definitely make a separate video for that. I'm not going to discuss this formula right here. The proof part I'm not going to discuss here. So you remember this as a formula. So if I want to know the exponent of the prime 7, the formula is this. So let me just generalize this. If I want to find out what is the exponent of R, in hyperfactorial n. So you will simply write this thing as R sigma t starts from 1 to box n by R t plus R square sigma t starts from 1 to box n over R square t plus R cube sigma t is from 1 to box n by R cube t, and this thing goes on till infinity. This will be the coefficient, the exponent of R in the hyperfactorial, n. Okay? So remember this as a formula. Now we can verify this formula by using a very simple example. Let us say, what is hyperfactorial for, say, 5? It is basically 1, 2 square, 3 cube, 4 to the power 4, 5 to the power 5, right? Now I am interested in finding out the exponent of 2 in the hyperfactorial 5. We can easily see from this, that is why I have taken the simple example so that we can verify the formula. Here we are having 2 square, here we are having 2 square, and from here we are actually having 2 square, that is 2 to the power 8, right? Therefore, the exponent of 2 will be 2 to the power 10. Now I will try to use this thing by means of this formula to verify whether our answer, that is the exponent of 2, is coming to 10 or not. So what I will write? Here I will write, we want to find out the exponent of 2. So it is 2 sigma t starts from 1 till how much? It is, here your n is 5. So it is 5 over 2 t plus 2 square. T starts from 1 till 5 over 2 square t plus 2 cube. T starts from 1 to 5 over 2 cube t, and this thing goes on. No need to write anymore because the upper limit is coming to 0. So in this case what we are going to have, 2 times sigma t is from 1 to 5 divided by 2, it is 2 point something, so it will be 2 t plus 2 square. T starts from 1 till 5 divided by 4, it is 1 point something, so it is coming to 1 only. The rest will come to 0. Okay? So our answer is coming to 2 into, this is basically 1 plus 2, this is 2 square, only 1. So it is coming like 3 to 6, 2 square is 4, you see we got the answer as 10. So you can take different values, take small values. Hyperfactorial of 7, 6, maximum you take 8, so that you can verify that this formula is working to find out the exponent of any prime numbers in that hyperfactorial term. Is it clear to all? Okay, one very interesting thing is that from the hyperfactorial we have seen that it can be written as 1 to the power 1, 2 square, 3 cube and so on. So it will be n minus 1 to the power n minus 1, then n to the power n and so on. So can we form a recurrence relation? Can we find a recurrence relation in hyperfactorial? Yes, why not? Hn can be written as, still this, look at carefully, this is basically what? This is basically hyperfactorial of n minus 1 and n to the power n is there. So this is the recurrence relation of hyperfactorial. Hn is n to the power n, Hn minus 1. Is it clear to all? Absolutely. Okay, so we can do one thing. Let me just put n equals to 0. Let me put n equals to 1. Sorry. Let me put n equals to 1. So what we are getting? H1 is 1 to the power 1 into h of 0. Now, h of 1 is what? H of 1 is nothing but 1 to the power 1, which gives us 1. So this is basically 1, which is equals to h of 0. Therefore, hyperfactorial 0 is basically 1. Hyperfactorial 1 is 1. Okay? So these are the initial values of this recurrence relation. Clear? So we have understood what is hyperfactorial. We have understood the recurrence relation of hyperfactorial. At the same time, the most important thing, we have learned how to find out the exponent of any prime in hyperfactorial. Right? Now we are going to take a very, very interesting problem based on this. See this question. In this question, they have said, consider the highest power of 5 in the product this. This is what? This is the hyperfactorial n. Is given by Hn. So what is Hn in our case? In this case, your Hn is the highest power of 5 in this product. Your Hn here is not representing the hyperfactorial. As in our theory part, we have taken Hn as the representation of the hyperfactorial n. But here they have said your Hn is the highest power of 5 in this product. It's okay, no problem. So let us say the product which is given here be represented by P. Okay? And Hn represents what? Hn represents the exponent of 5 in P. Okay? That's exactly what they have written. That is, Hn denotes the largest integer k such that 5 to the power k is an integral divisor of the above product. That is, the k is the maximum value of the exponent of 5. That's exactly what they are saying. Now you have to find out the value of limit n tends to infinity n square by Hn. That's the question. Very interesting sum. What I will suggest to you, you pause the video right here and give a try to this sum. Okay? You will learn a lot of things out of it. Okay. So my first task is to find out what is Hn. So to find out Hn, we have to find out the exponent of 5 in P. And how to find out the exponent of 5 in this product? It will be, the exponent of 5 will be, which is actually your Hn, this will be what? It is 5, because I have to find out the exponent of 5. So 5 sigma r starts from 1 n over 5 t. I should not write r here. I must write, I can give r also, no problem. If you want to give r, give r. Okay. So this is your r plus 5 square. Again, r starts from 1 box of n by 5 square r plus 5 cube sigma r starts from 1 to box n by 5 cube r And this thing goes on. So this can be written like sigma of R starts from 1 infinity 5 sigma. Oh, I have already taken R over here now. So let me take K here. Let me take K here. It will be better to understand. Otherwise, both the R's will be mixed up. K starts from 1 to infinity, 5 to the power K, and your R starts from 1 till box of n by 5 to the power K R. Is it clear to all? Have you understood this? This thing I have written in this way. If you have not understood, please pause the video right here and try to understand first. Then only you will understand the next step. Okay, so now observe carefully. This is basically an integer. This is an integer. N divided by 5 to the power k. It is an integer. So this sigma actually represents what? It is basically 1 plus 2 plus 3 plus till box of n divided by 5 to the power k. For a time being, let me just denote this thing by m. For your simplicity, I am taking that thing as m because m is an integer. Okay? So this sigma will give us what? K is from 1 to infinity, 5 to the power k. This sigma is going to give you the sum of first m natural numbers. So it will be m into m plus 1 divided by 2. So this is basically, if I replace my m here, we are going to have box of n over 5 to the power k into box of n over 5 to the power k plus 1. Is it clear or not? Till this, is it clear or not? Okay, so now we know that box of x always lies between x minus 1 and x. Box of x always lies between x minus 1 and x. Do you accept this? Okay. So now can we write this? Look it very carefully. Very, very carefully. Box of n by 5 to the power k into box of n by 5 to the power k plus 1. This lies between n by 5 to the power k into n by 5 to the power k minus 1. Because box of x is always greater than x minus 1. That's exactly what I have written here. And it will be less than n by 5 to the power k into n by 5 to the power k plus 1. That's it. Box of x always lies between x minus 1 and x. That's exactly what I have written here. Now, I am multiplying all the sides with 5 to the power k. And now I am taking sigma on both sides. Sigma k is from 1 till infinity. See one thing, 5 to the power k will be cancelled. So it is n into n by 5 to the power k minus 1 is less than equals to 5 to the power, sigma is there. Sigma k is from 1 till infinity, 5 to the power k, n by 5 to the power k, the same thing I am writing. Less than sigma k is from 1 till infinity. Again 5 to the power k will go off. So it is actually it will be n into n by 5 to the power k plus 1. Okay. Now, one thing I have forgotten to write here, there is a half. This 2 will come outside. Okay. So let me just multiply with half all sides. So half is here. Half is also here. Now, what is this? This is basically your Hn. This is your Hn. So, what we got? We got half. I'm writing it here. I got half sigma. Let me take. Okay, I will do it later on. K is from 1 till infinity. N into n by 5 to the power k. Or I can do one thing. I can take one n common. I will take one n common, so it will become n square 1 over 5 to the power k minus 1 over n, which is less than equals to your Hn less than half sigma k is from 1 till infinity. Again, you take n common, so n square is outside 1 over 5 to the power k plus 1 over n, right? Now, let me divide both sides by n square. N square, it does not contain any k. So I can take that n square outside the sigma sign in both sides. And now I'm dividing both the sides with n square. So we are left with half k is from 1 till infinity minus 1 over n is less than equals to Hn by n square less than half sigma k is from 1 till infinity 1 over 5 to the power k plus 1 over n. Am I correct? Now if I reverse this, so n square over Hn, it will be greater than 1 over half sigma k is from 1 till infinity 1 over 5 to the power k plus 1 over n is less than equals to 1 over half sigma k is from 1 till infinity 1 over 5 to the power k minus 1 over n. Is it clear now? Now, if I take limit on both sides, what we will get? This case, if I take limit n tends to infinity, so what we are going to have? Let me take this thing in the next page. So now if I take limit on both sides, limit n tends to infinity 1 over half. Let me do one thing. Let me just simplify this. K is from 1 till infinity 1 by 5 to the power k plus k from 1 till infinity 1 over n. Okay, I've simply separated it. So this is basically an infinite GP series whose first term is 1 over 5 and the common ratio is also 1 over 5. So this is going to give us 1 over 5 divided by 1 minus 1 over 5 plus this part, let it be like that. So this thing is coming to half. This is 1 over 5 into 5 over 4 plus sigma k is from 1 till infinity 1 over n. So this is actually coming to 1 over 8 plus half sigma k is from 1 till infinity 1 over n, right? Similarly, if we simplify this, the second part, that is half sigma k is from 1 till infinity 1 over 5 to the power k minus 1 over n, we are going to have actually 1 over 8 minus half sigma k is from 1 till infinity 1 over n, right? So let me just replace this over here. So we are having 1 over 8 plus half 1 till infinity 1 over n is less than limit n tends to infinity n square by hn is less than equals to limit n tends to infinity 1 over 8 minus half sigma k is from 1 till infinity 1 over n. Okay? Now, this is actually the limit we are going to find out. Isn't it so? We have to find out this limit. Let me just denote this thing by L. So your L becomes, L is lying between greater than, now look it carefully. This is basically 1 over, now in this case, observe carefully, 1 over n, it does not contain any k. So I can take outside the sigma sign. And as n is tending towards infinity, so this part will become 1 over n will become what? 0. Yes or no? As n is tending towards infinity, 1 over n will be tending towards 0. So this part will become 0. Less than equals to 1 over, similarly it is 1 over 8 minus 0. So your n is greater than 8. That is this limiting value. Which limiting value? Limit n tends to infinity n square over hn. This is lying between 8 and 8. That is greater than 8, less than equals to 8. So from the sandwich theorem, we can say that limit n approaches to infinity n square over hn is nothing but 8. And that's your answer. A wonderful sum, a wonderful sum. Not only your hyperfactorial is involved in the question, at the same time, the limiting thing that has been mixed with this question has taken this question to a next level, right? As well as this limit is not a very simple limit. This limit is not a very simple limit. Here at last we have used the sandwich theorem to find out its value. Okay? So I hope you have enjoyed this class. See you tomorrow. Till then, take a very good care of yourself. Thank you so much.